Hi, I'm Paul Garden, Product Marketing Director at Tensilica IP Group at Cadence. Today, I'm going to talk to you about our newest DSP processor, the Fusion G3. I'm going to talk you through some of the block diagram here, and I'll explain some of the features of our brand new DSP, the Fusion G3. Okay, so at the heart of every single DSP that Tensilica makes or Tensilica customers create is an extensor 32-bit CPU or processor. So the Fusion G3, like every other Tensilica processor, has the extensor processor at the heart of it. In this particular case, it's the newest LX7 extensor processor. This takes care of all the real-time control in your application. To work with the processor are some scalar 32-bit registers. So this is common to all the other Tensilica processors, making it co-compatible and very familiar for customers using them. So the main part of the Fusion G3 DSP is the 128-bit Vector Dsp. This is the main integer processing unit of the Fusion G3, which features 4 32 by 32-bit Macs, giving lots of performance. And then, depending on the data type you're using, you can have 4 32-bit Macs every cycle, or 8 16 or 16 8-bit Macs per cycle, giving you lots of throughput. To feed the Vector DSP, we also have a set of vector registers here. And to bring the data and the instructions into the processor, we have a data interface, which is 128 bits here, and also an instruction interface, which again is 128 bits. So we can actually have different types of memories. We can have SRAM, ROM, or caches on both the data and on the instruction side. Here we have some management of the DSP. So that is things like interrupts, debug, real-time trace, that kind of stuff. Here we have a load store plus a separate load unit, both of which are 128 bits also. So these are responsible for pulling in large amounts of data to feed the DSP to give it its performance. Also featured in the Fusion G3, we have a programmable memory protection unit allowing you to protect areas of memory. We also have, which is a very key feature, is the vector floating point unit, which supports both single and double precision floating point. Now, this has 4 floating point fused multiply accumulates. So it's 4 FMAs, or they are floating point max, single precision max. And it does support single and double precision. Also, we have an IDMA, which is an integrated DMA controller, which you can use to hide the latency of getting data from outside of the memory, outside of the processor, from system memory onto the processor. So to connect into the rest of your SoC, we have a bus interface which supports AXI and AHB Lite, and also ACE Lite. So this is effectively an overview of the block diagram of Fusion G3. Some of the applications that it's used for, it's a very rich DSP instruction set, so it can be used for many, many different applications, including audio pre- and post-processing, radar processing, and there will be a Whiteboard Wednesday talking about using Fusion G3 to do radar applications. Also communications and low-end imaging. So to make everything work, we've got to have some good software. So on the software side of things, we have one of the industry leadings auto-vectorizing compilers, making it very easy to program in C. And also, we have a DSP library, which has over 550 DSP functions to make it easy to write the software. So there we have it as an overview of Fusion G3. That's it for today, and I look forward to seeing you on another Whiteboard Wednesday.